So we did elastic collision in 1D, and in this reference, few formula were extremely important. That's why I'm writing it again. V1, if we want to calculate velocity of the first body after collision. Remember, when we calculate this velocity of first body after collision, so after collision, what will happen? If you calculate V1, it was first minus second divided by total. First minus second divided by total. And you first will take first value, then second value. And here mass will be taken second by total mass. Okay. So if you see this, what is happening in this case? Keep in first context, one is important. That's why one is taken first. In second case, second is important. That's why it is taken second. Because this formula is usually long and you might miss some important point. Correct? After collision, V2 value will be in the same way. You will take M2 as the important part first, then M1 multiply by U2 divide by total mass. In denominator, there will be only total mass addition to M1 U1 divide by M1 plus M2. Okay. So these two things we did in the last class and extremely important. As I'm telling you again and again, we will do lot of questions from this topic only, and you can do different cases of this key. What happen if you take two important situation? If M1 and M2 both are exactly same, then V1 will be equal to U2 and V2 will be equal to U1. Exchange of the velocity, simplest way. Exchange of the velocity if they are moving the same way. Second possibility, if one mass is way more than the another mass, what and one body is at rest like truck and cycle. So what will happen? Velocity of the first body will go in the opposite direction, like cycle will hit the truck and come back, and there will be no impact as such in the truck. That's why it is approximately zero. This is what we did in the collision, and this is what we are going to use in the questions also. Any doubt, guys, here?
No, sir.
When it comes to the inelastic collision, though I will do it, definition is important, derivation is not. Okay, derivation is not. So be careful about this. Ki when you are spending time, understanding is important, not memorizing the thing. Here, this is more than sufficient what we did as of now in collision. And now we are talking about perfectly inelastic collision in 1D. Perfectly inelastic collision in 1D. Okay. So what happened in elastic collision when two body collide with each other? They will stick together and they move as a single body with a common velocity after the collision. Okay. Then this collision will be known as the perfectly inelastic collision. So if anybody asks ki what is the perfectly inelastic collision, you will say ki when two bodies collide and they stick together, both body stick together, and after that they move as a single body with common velocity. with common velocity. We have seen very recent question uh, in this top from this topic with common velocity. So you will say कि this is perfectly inelastic collision. You will take same situation कि you have body A with mass m1 and initial velocity u1. Then you take second body mass m2 and second velocity is 0. So this is before the collision. After collision, what will happen? The velocity, both the body will stick together like this, m1, m2, and they are moving with common velocity v. Any doubt, guys, in this?
No, sir.
Pratigya, Jordan, Barinder.
No,
Yes, sir, understood.
Because trust me, if you understand this, 90% job is done in elastic collision. You have two body, they stick together and they move with a common velocity. Because here you have common velocity, and also part is one body is not moving initially. Understood? Initial velocity is 0 for one of the body. Got it? Even whether it is elastic collision or inelastic collision, you know linear momentum always remain constant. So we will apply linear momentum will remain constant. Linear momentum will remain constant. Correct. So m1 u1 plus m2 u2 will be equal to m1 plus m2 v. Correct. Because both mass are moving with the common velocity. That's why u2 is 0. And if u2 is 0, what will be the v value? m1 u1 divided by total mass m1 plus m2. Yes or no, guys? Any doubt? And this was the question. I'll show you. Uh, very recent question. Mm, this was the question, I guess. But you can solve both the question. Two body A and B have same mass. Remember, same mass. Undergo completely inelastic collision. Same mass in elastic collision. Body A move with velocity v1 while body B at rest before collision. Okay. Velocity of the system after collision is v2. What will be the ratio? See this question I was talking about.
2:1.
Correct. So what you have to do
Answer
is
B.
answer B. I don't know. I have to check, but probably it could be this. Hey, both mass are same. So if you apply linear momentum m u1, which is v1 here, is equal to m1 plus m2 means 2m v. So v2. and it is asking V1 by V2. What will be the value? 2m by m. 2 ratio 1 b. Tell me, guys, was it extremely easy? Direct formula of application of linear momentum m1, which is m, u1, which is v1 given here, m2 m, and u2 0, u2 0, correct, is equal to, because it is a perfectly inelastic collision, m1 m2, and this velocity is given, and m1 m2 is equal to, this is equal to 2m. M will be cancelled out. V1 by V2 will be 2 by 1. Done. Tell me, does it take very long time? Does it take very long time? Is it difficult? Yes or no, guys? Hello?
So got it. Understood.
Yes. So that's why I said ki here question will be easy to solve. You will feel like ki collision is one of the difficult topic. Here question will be the most easiest to solve. When it come to the kinetic energy, if you see kinetic energy before collision, then you know you only one body is moving. So your kinetic energy initially will be half m1 u1 square, correct? After collision there is a common velocity v. So we can say kinetic energy will be half total mass is m1 plus m2, and total velocity is v square, correct? Make sense? If you put first energy value, then what we can say, uh, you can put this value v also, depend upon the situation. So can we say kinetic energy of second is equal to half m1 plus m2 is common, and instead of this velocity v square, can we put this value above v m1 u1 and all this stuff, correct? We can put. So v square will be m1 u1 divided by m1 plus m2 the whole square, correct? Can we also say कि final kinetic energy will be equal to half m1 square u1 square divided by total mass? Yes or no? Now they can ask you what is the total kinetic energy, and here it will help you out to understand. Again, I'm telling you, don't remember formula, just follow the process. If you forget formula, you can still figure it out. Even during exam, you get enough time. And last question they can ask is, what is the loss of kinetic energy in this situation? What is the loss of the kinetic energy? Initial kinetic energy was kinetic energy 1, and final kinetic energy is kinetic energy 2. There will be some difference. What is this value? Half m1 u1 square minus second value half m1 square u1 square divided by m1 plus m2. This is how you can calculate the difference in the kinetic energy. This is the known as loss of kinetic energy, delta kinetic energy. Okay, if you see half will be common, and your, but again, the problem with the most of the student is they will try to memorize the formula, and don't do this, because you have seen in 2025 you can't, you have to solve everything. That's why you have to increase speed of the derivation, correct? If you see this overall kinetic energy is positive because you don't have any negative sign. So this is positive. And if it is positive, its simply meaning is kinetic energy will be lost in the form of light, sound, or heat. Correct? Kinetic energy is lost in two, three forms. Mainly, some light is produced, some sound is produced, or some heat is produced when they stick together. Tell me. But majority of time they will ask question only from this. Any doubt?
No, sir. No, sir.
No,
Everybody is
sir.
okay with that? Okay. Because now, if you understood 1D, then we can do 2D. How is your topic, by the way, this topic, Pratigya?
Go.
How is this topic for you? You are
बहुत
really
easy
good in
लग
it
रहा है.
or you always scared? मतलब तुम्हें डर लगता है कि अरे ये आ गया topic.
नहीं.
हम्म, बोलो.
नहीं सर अच्छी है.
So good. Jordan.
Yes, sir. The topic's okay for me.
Okay. Barinder. सर पहली बार अच्छे से पढ़ रही हो.
Yes, sir.
Hara.
Yes, sir. The topic is fine. I mean, formulas are a bit confusing for me.
Hmm. We don't need to remember formula except this V1, V2.
Okay, sir.
You have to apply one basic thing everywhere. Conservation of linear momentum. That's all. Okay. Conservation of linear momentum. Linear momentum will remain conserved. In case of elastic, kinetic energy is also conserved. That's all. Trust me. That's what I'm trying to convey. Ki people will assume ki you have to remember a lot of formula like this. No, I am deriving it. I'm not saying ki you have to remember. What we need to do is only linear momentum conservation and kinetic energy conservation only in case of elastic. Linear momentum conservation applied everywhere, whether it is elastic or inelastic, where m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. This is what you will apply everywhere. See, even in this situation, we applied same thing. Velocity was common, u2 was 0, and we got the formula, but this was the thing. You will apply kinetic energy conservation only in case of elastic collision. Only in elastic collision, nowhere else. And if you do this, then it will be half m1 u1 square half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. That's all. You don't need to apply anything else other than that. And majority of time only this, nothing else. Trust me, if you understand this, your chapter is done. And what is happening?
Sir,
हाँ प्रतिज्ञा।
तो लीनियर मोमेंट कंजर्वेशन में वो लास्ट वाला B2 होगा ना?
हाँ हाँ, सॉरी सॉरी, दिस इज V2। करेक्ट। So that's all you need. If you are focused only on this and you are like whatever else, depending upon the situation I can solve, then you are perfect in this topic. You will never do mistake. But if you try to memorize every situation formula, even V1, V2, it will take long time. Though V1, V2 formula are cru- crucial because, like what I say, they are very common. That's why people try to memorize it. Focus on the next topic, elastic collision in 2D. Okay. And this collision is also known as oblique collision. Why? Because after collision, body will move obliquely. That's why oblique collision. Okay. So what happened? Same thing. This time you will talk about only 2D. Example, this is y-axis. Here you have two body. First mass m1 moving with u1 speed, and there will be m2 on the x-axis only and moving with u2 speed. Correct. So this is u2. This is A body and B body. When they collide in x-axis, what will happen? They will move obliquely. Example, if you consider this y-axis, if you consider this as x-axis, compared to x-axis, one body, example A, is moving in this direction. B is moving in that direction. Okay, this is B, this is A. Okay, so what is actually happening in this case? You will see two component, y-axis and x-axis. Example, if you take this body is making angle theta. This body is making angle with the x-axis phi. You can take theta 1, theta 2 also, doesn't matter. What will happen? You know this will be the v1 velocity, correct? It is moving with some velocity. You will consider two components. One is base component, which will be v1 cos theta, and another in the upward direction will be v1 sin theta. Correct. Same here. If it is moving with velocity v2, like this is v2, there will be two component. If you take this phi, this will be v2 cos phi, and this will be v2 sin phi. Correct. This is. Tell me, you have any issue in this situation? Any doubt, guys? Ki how it is making angle? Ki initially you have two body, have specific mass and velocity. When you take u2 as zero, you consider ki second body is not moving. Now what will happen? A body is making some angle with x-axis and B body is making some angle with the y-axis. Okay, some angle with x-axis, some angle with the y-axis. So what will happen? You have to consider two component, cos theta and sin theta. Exactly same thing you did in the linear momentum conservation also. Like bomb blast, right? Bomb explode. Do you remember, guys?
Yes, sir. Yes, sir.
Yes, sir.
Exactly, you have same thing here. Also, in this situation, This, what should I say? This collision is not head on. It is not head on collision. So what will happen if it is not head on? Only one tip, like base of A body is hitting B. What will happen? They will move in the different direction. If they are head on, head to head, then they will move linearly. Make sense? Right? A, if there is a head on collision, example, this is A and this is B, both look exactly head to head. So they will move in the linear motion. But example, if one body A is here, B body is here, both are in x-axis, what will happen? A will hit the B and then they will move in the different direction. Correct? Best example is your this which board is this where you take stick and then hit the ball?
Baseball.
No, 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 no. On the table. Is this snooker or something else?
Table tennis.
No, 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 not table tennis.
Then
There are a lot of balls on the table and you hit them and then you put in the like you hit the it is like carom board but with the stick. I forgot this name. Probably it could be snooker or
snooker or pool. Understood, sir.
like a pool.
Pool
Is
is
this
smaller, snooker is larger.
this one? Yes, it
Yes,
is
sir.
snooker. This one I was talking about. This is the simplest classical example of how collision occur in this ball and they are moving in the different direction, right? 2D. They're not moving exactly straight. If you hit in the middle, then it will go straight. But if you hit left or right, then both the ball will move in the different direction. Simplest example of elastic 2D collision, not head on. Make sense? Any doubt?
No, sir.
If you understand this, again, I told you, same basic principle, linear momentum conservation. You have to apply, same apply, you will hear. So so what will happen? U2 is 0. Can I say formalize M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2? Correct. M1 is M1, U1 is U1, M U2 is 0. Correct. U2 is 0. That's why it will be like this. If you see along the x-axis, V1 along the x-axis will be M1 V1 cos theta, cos theta. Yes. And M2 V2 will be cos phi. Yes or no?
Yes, sir.
Any doubt? Now you do same thing along y-axis. What you will see here, it is the same thing like in 1D elastic collision. It's just ki you are doing two type, one in x-axis, another in y-axis. So what's the problem? Nothing. So in case of y-axis, initial momentum is 0 because both the ball were moving in the x-axis. This is y-axis. This is x-axis. So they were not moving in y-axis. Formula will be same. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So this value will be 0 because in y-axis there is no movement as such. Now look at the m1 v1 value. In v1 value, v1 sine theta is in upward direction, so positive. Correct. So I will write here m1 v1 sine theta in positive direction. But if you see v2, it is in the downward direction. That's why negative. So it will be m2 v2 sine phi. Yes or no, guys?
Yes, sir.
So you can say m1 v1 sine theta will be equal to m2 v2 sine theta, sine phi, sorry. Done. And again, when we are doing theoretical part, na, you will use in the question, and you can trust me, simply do linear momentum conservation, nothing else. Okay. And last is kinetic energy. Here, how to calculate kinetic energy in this situation? Same thing. First, u2 is 0. So this kinetic energy will be 0. So it will be half m1 u1 square is equal to half m1 v1 square plus half m2 v2 square. Done. Correct. Depend upon the what is asked, you can calculate. Done. Okay. And let me tell you what can be asked in this. V1, V2, theta and phi. Nobody will ask more than that. You will calculate four things. Calculate four things. One is what is the V1 value, what is V2 value, what is theta value, and what is phi value. Done. Nothing else. Understood? And you can calculate based on that. Done. But nobody asked difficult question here. That's why you have to consider different cases. Like different cases. Case 1. Glancing collision. Pratigya, what is glancing collision?
सर फर्स्ट टाइम मैं वर्ड सुन रही हूँ.
First time you word सुन रही हो. So in glancing collision, incident particle does not lose any kinetic energy. And it gets scattered without any deflection. Okay. So what will happen? Particle that is moving do not lose any kinetic energy and scattered almost undeflected, means in the same direction. Okay. Incident body does not lose any kinetic energy. Okay. Spelling of does not lose any kinetic energy. And if it does not lose any kinetic energy, it will move undeflected. And when you understand this, you should get one point. In this case, theta will be 0 because it is moving in the straight line. And phi will be 90 degree because other body will move perpendicular. This you should understand just by word glancing collision. This theta is 0 and phi is 90. Understood? If this is the situation, tell me, what should be the velocity of first body? It is not deflected. So V1 will be same as U1. No difference. We said no difference in kinetic energy, it means same. Second, if you calculate V2, you will see it will be 0. Then so this is glancing collision. So why I'm telling this? In question they will give you the body is having glancing collision. Calculate what is the final velocity and of both the body. You can directly calculate whatever is given the incident. Done. Final 0 v2 done. And that's what happened. Like in most of the cases, you don't understand the language of the question. You know how to calculate, you know formulas, but you don't know how to apply in the question. What does the meaning? Okay. Second, very basic head-on collision. That is the most common collision we study at this level. Head-on collision. If you hit exactly in the middle. In this situation, you know phi will be 0. Correct. Second body will move in the straight line. So in this case, phi will be 0. Correct. And if phi is 0, what will you see? M1 U1 is equal to M1 V1 cos theta in x-axis, cos theta in x-axis plus M2 V2 cos phi, and phi value is 0 and cos 0 value is equal to 1. Correct. This is in the x-axis. If you do in the y-axis, this is 0. What is this? M1 V1 sin theta plus, sorry, minus M2 V2 sin phi, and you know phi value is 0, so it will be 0. It will be equal to m1 v1 sin 0. Yes or no, guys? In y-axis. So you have to do same stuff head-on collision in two axes. One x, second y. Any doubt?
No, sir.
And case 3 is very lengthy. I will not go for it, but I will tell you summary. If this is perfectly elastic collision and two identical body means mass is same. Identical body means mass is same. If in this situation m1 is equal to m2 is equal to m, and you calculate values, then you will see theta plus phi both will move perpendicular to each other, and that's what you have seen in the normal linear momentum also. Both angle will be exactly 90 degree. They will move perpendicular to each other, nothing else. Understood? Any doubt? We are just left
Yes,
with
sir.
the 10-minute topic, then we can solve question. Just give me 2 minutes. Right question. These are the billiards ball, na? Billiards game. Snooker, billiards.
Yes, sir.
Hmm. Calculate.
See,
Yeah. Done, guys.
53 आया मेरा।
कितना 53?
हाँ
53. See, whatever you do, you know both angle is
90
90 degree. Both theta 1 plus theta 2 are present at 90 degree. If theta 2 value is 37, then theta 1 value will be 53. Done. Correct. Any doubt, guys?
No, sir.
And this question, why I am writing the questions? Because when you read the question, now you will feel, oh my God, such a difficult question. It will
Yes,
take a
sir.
lot of time. है ना? ऐसा लगता है ना
हाँ
कि
सर।
like
Yes, sir.
such a long difficult question. I don't know how to solve such question. Nothing is given. Only two mass are equal, and only this angle is given. How will I get the angle, another angle? But what I told you through this case, he when in elastic collision two body are identical and their mass is same, then angle will be 90-degree done. That's why I didn't tell you all the derivation. I know where derivation is required and where it will stress you. That's why I didn't do, and this was enough. By the way, I didn't draw the diagram. I will draw diagram also. Oh, that's why it became easy. I didn't draw diagram. Diagram was like you have a body. This body have mass m, a, and this body is moving with the speed u1 is equal to 0.5 meter per second. Okay, it hit the body b, which mass is again m, but its initial velocity is 0. Okay, a body is moving like this, mass m, a body is moving like this, and its speed v1 will be equal to 0.3 meter per second. And then another angle, this b body, mass m, and v2 will be, v2 is not given. And if you see, both of these body will be perpendicular to each other. If both are perpendicular to each other, then it means your theta 1 and theta 2 total will be 90-degree. Correct. Even if all the values is given, doesn't make sense. Like, doesn't need, we don't need that, right? Make sense, guys?
Yes, sir.
Just last 10 minutes, few important point. Coefficient of restitution or coefficient of resilience. Have you heard this name? हम्म
होगी महास्तुति गासा
बहुत बढ़िया. देखो मेहनती लोग हो तुम, न्यूएल लागे रहे करो. Jordan, have you heard about this coefficient of restitution?
No, sir.
Wow.
I
और
might have forgotten also.
प्रतिज्ञा?
हाँ सर, समथिंग U1/U2 कुछ था।
हाँ. So, by the way, let me tell you one thing. People who know less, they always have advantage compared to the people who know more. Let me tell you, NEET is not about how much you can remember now, especially Jordan and Pratigya, you. It is like how much you can forget from unnecessary stuff. It's difficult to forget.
Oh, no, I've forgotten everything. Trust me on that.
Good. If you forgotten everything, it's really good. Because example, Sarah and Barinder are doing it for first time. They will read limited thing this year. They have very high chances. But people who have example multiple drop. One of my friend is 5 year like dropper. Every time he is reading new stuff, and because of that, he's not able to forget the previous 5 attempt content, and that's why every time he's not able to crack the exam.
Sir,
5 year
I
drop
don't
or
know
even
nothing.
you don't know anything.
Yes.
It's good. Trust me, if you forget previous thing properly and remember what I am teaching is more than enough because I teach the least. You must have seen, right? Least. Jordan, if you compare your coaching institute notes and my notes, it's way lesser than that, right?
Oh my God, trust me, sir. Yes.
Why? Because I know what is required. Last year we did the same thing, and that was sufficient to solve question, right?
Yes, sir.
Jo- Exactly, that's the point. So when we talk about the coefficient of restitution or coefficient of resilience, it is simply what is the relative velocity of separation after collision and before collision. What is the difference? Correct? What is the difference in the velocity? Relative velocity after collision and relative velocity. We call not after collision, we call it as relative velocity of separation. And this relative velocity of separation you talk about after collision. To make it easy, I always write after collision. And this is relative velocity of approach. When they are approaching each other, it means it is happening before collision. Correct? So, can I say relative velocity of separation is final velocity minus initial velocity? And the relative velocity of approach is u1 minus u2 because u1 was more. That's all. Done. This is the coefficient of restitution. Coefficient of restitution. Done. So coefficient of restitution value will give us the by what degree they will restitute. Example, if E value is 1, it means it is perfectly elastic. And if E value is 0, then it is perfectly inelastic. If E value 1, then collision is perfectly elastic collision. And if E value is 0, then perfectly inelastic collision because they will stick together. If they stick together, V2 minus V1 will become 0 because they are common. Make sense? In case of perfectly elastic, both value will be same. It is 1. And in any other collision, this coefficient of restitution will lie between the perfectly elastic and perfectly inelastic. Any doubt? I think you got this question last year. Somewhere I have seen. Okay, no problem. Last topic of the chapter and then work energy power will be done is the rebouncing of the ball. Rebouncing of ball. You know what happen if you have elastic collision, then if you drop the ball will come to the same height. Correct? But in reality, it does not happen. It will always reduce. Example, first time when ball is falling from h height, like this, h height. Second time it if it is go second height will be usually less. Third height lesser. And it keep on reducing and after some time automatically ball will stop. That is what happens in real life. Correct? If you drop a ball, it will bounce 2 3 times and then it will stop. Make sense? What we are saying ki every time height will be different. Okay. In every situation, height will be different. How to calculate height after n number of impact? You want to calculate what will be the height after 2 bounce or 3 bounce. So height after n number of impact. And this height will be equal to e raised to power 2n into h, coefficient of restitution. Okay, coefficient of restitution, and after that, ultimately it will come to the rest condition. Okay, ultimately it will come to the rest condition. If you want to calculate what is the total distance traveled by the ball, total distance like this from here to here, what is the total distance traveled by the ball? So how will you calculate in this situation? This s value, total distance travel, will be depend upon h height, 1 plus e square divided by 1 minus e square. Trust me, not um, many time need ask this question. Rarely, but still, because it asked one or twice, so if you can do it, good. If you can't do it, you can leave it. Okay. So what is this s? S is the total distance traveled by the ball before coming to the rest. Distance, remember, distance. Wait. My bad. Not this distance. Total height, like it is going up, down, up, down, up, down, up, down. How much distance traveled by this? That is S, not displacement. Total distance traveled by the ball. That's why you will see logically it should make sense by ball. Why? Example, I made mistake and I said, ki, okay, this is the distance S. Logically, it's not possible. It is displacement. And most of time, body will, example, this is the body. It come down, again it reach up to here, come down, again reach to here, come down, again reach here, come down. What is the displacement in this case? Zero. Logically, it is not suitable. This distance. Make sense, guys? Yes or
Yes,
no?
sir.
That's why it is the height cover h1 plus h2 plus h3 plus h4, this total addition. That is what we are talking about. Right. So this is all. And now I can make a extremely short summary of few things because chapter is done. Okay, chapter is done. See, example, we want to see what kind of collision we are talking about. One, what is the impact on the kinetic energy? What is the E-value coefficient of restitution? And where it
सर वो लास्ट
happen?
पॉइंट पे देखिए,
Example. Yes, Pratigya.
वो जो डिस्टेंस के बाद लिखे थे ना पॉइंट, थोड़ा स्लाइड अप करिए.
This one.
ओके सर, डन हो गया सर.
Done.
हाँ.
So, अरे, yeah. So we have different type of collision here. First was elastic collision. In case of elastic collision, kinetic energy remain conserved because linear momentum is always conserved. E value is equal to 1. And this happen between atom particle, atomic particle, correct? Electron, proton, neutron, because only their elastic collision is possible. Second is inelastic collision. In case of inelastic collision, kinetic energy is not conserved. Kinetic energy is not conserved. So E value will be more than 0 and less than 1. And normal body normally have this type of situation. Correct? Then perfectly inelastic collision. In this case, there will be maximum loss of loss of kinetic energy, because both will move together. And here E value will be 0 because both are moving together. It happened during shoot. If you shoot and body will move inside, like this bullet, or like what is this?
Gun.
What? Yeah, through not the normal bullet. You have some pallet kind of thing, or this arrow type come out of the gun. Jordan, have you seen this for the games purpose? Arrow kind of thing. Like how do you throw on
I
your home?
I think I not talk about so that bullseye game no.
Yeah, bull eye game.
No, I
Exactly.
know. I know what it is.
Bull eye game. This, like you hit this. So
Dartboard,
initially
huh?
body was moving, and then ultimately both came to the rest. Oh, this name is dartboard. Okay, dart. Correct. And it could be sometime, though it is rare, we don't have in our syllabus, super elastic collision. You must have seen some super elastic ball and where kinetic energy increase, like you throw from the height, and in this case E value is more than 1 and it happen in explosion. Kinetic energy of the particle will increase because initially it was 0 or very less, and then suddenly explode. Kinetic energy is more. Make sense? And with
Yes,
that,
sir.
this full topic is covered. Remember, linear momentum is conserved in any situation. Got it? And if you ask me, ki, sir, can you do quick revision of this? Actually, we already did the quick revision. Remember, we did elastic collision when two body collide with each other. Here, linear momentum remain conserved as well as kinetic energy remain conserved. Okay. And in this case, if you calculate V1, it will be M1 minus M2 by M1 plus M2 U1 plus 2 M2 U2 by M1 plus M2. Correct? V2 M M2 minus M1 U2 divided by M1 plus M2 plus 2 M1 U1 divided by M1 plus M2. This is what we did in case of elastic collision. In case of perfectly inelastic collision, what happen? One body is not moving, and final velocity V1 is equal to V2 is equal to V. That is the situation. Everything else you can apply the linear momentum conservation rule. Correct. And then what else happen in case of elastic collision? If it is 2D, two dimensional, then you will consider everything separately. In x-axis, what is the value? In y-axis, what is the value? And you will see that theta plus phi will be equal to 90 degree. Correct. And last topic is coefficient of restitution, velocity of separation divided by velocity of approach is the coefficient of restitution. Coefficient of restitution. And last of all, if you want to see height at a given point, it is equal to e raised to power 2n into h. See, this is the quick revision of the full collision chapter. Tell me, guys, is it easy to do? That's why when people are doing one shot na in 1 hour, I can do in 10 minutes. But for that, you need proper explanation. Revision is always easy, and that's why I tell you ki whatever we are covering in 1.5 hour or 2 hours, you should be able to cover it in 10 minutes. And trust me, nobody will ask you question more than this. No one. That's all. That is the only thing you need to understand here in this chapter. Even like you can write case if M1 is equal to M2, what happened, right? And so V1 will be equal to U2 and V2 will be equal to U1. And if one mass is greater than M2, then what will happen? First velocity will be opposite and second velocity will be approximately zero. Tell me, can you imagine anything out of this box from the collision chapter? Yes or no, guys? This is quick summary of the full chapter, including this. Yes, this page. Are you thinking, ki, sir, we spend almost 2-3 hours for this collision, and then how we are able to revise this in 5 minutes? I didn't take more than 5 minutes, right? Answer is because in first instance you need to understand each and everything. It takes time. Once you understand, it's just quick summary. Okay. If everything goes well now, probably what I am thinking to buy the digital board and to explain you through video and digital board. What do you guys say?
That will be cool, sir.
That will be cool, no?
Yeah.
Exactly. That's why I'm thinking about this. It just requires a lot of money, and that's what I'm thinking about. If I get it properly, then I will do it in this month only. Not too long. Okay, solve this question. 72.
Sir, answer C.
Answer 2.
C, C.
B.
Equal.
Equal. C.
Yeah.
Okay. Answer will be C. What happened? This word elastic collision is the most important thing here. If they give inelastic collision, then situation will be different. It is saying it is proper elastic collision. And in case of elastic collision, if mass is same, we discuss this case. If m1 is equal to m2, then what will happen? v1 will be equal to u2 and v2 will be equal to u1. Interchange of the velocity, correct? Exchange of energy, velocity, sorry. So what we are saying, ki transfer of energy will be maximum. Transfer of energy means no loss of kinetic energy, correct? No loss of kinetic energy. That is the meaning of maximum transfer of energy. When you don't have no loss of kinetic energy, when mass is same and you completely transfer the velocity. Like initially it was 60-40, later it become 40-60. No loss, perfectly same velocity. Make sense, guys? Solve this question. A body A, this mass 4m moving with this speed, collide with another body B, which mass is this at rest. Second body at rest, first body moving with some speed. Collision is head on and elastic in nature, perfect elastic. After collision, fraction of energy lost uh, by the colliding body A. See,
एक
first
अपन
calculate
है
kinetic energy of A in the initial situation, half 4m and u, correct? And when this happened, what will u square? So
to
it will
you
be 2m u square, correct? Because another body at rest. If it is perfectly elastic collision, what will happen? This B body will start moving and A will come to the rest, correct? So you have to calculate what is the velocity of the V2 first. First calculate what is the velocity of V2 in this situation. In case of elastic collision, what will happen? I will do it here. Where is that? Huh, this is a good question. What was the question number? 73. Here, first body mass is 4m, second body mass is 2m. This is moving with u speed, this is at rest. You have to calculate fraction of kinetic energy. First, understand what is the meaning of fraction of kinetic energy. Change in kinetic energy divided by original kinetic energy. Okay, change in kinetic energy divided by original kinetic energy. This is what you have to calculate. Original you already know. You have to calculate change in kinetic energy. How you will get change in kinetic energy? Initial kinetic energy before collision and final kinetic energy after the collision. Make sense? Any doubt? Any doubt, guys?
No, sir.
So, in this case, if you want to calculate V2, final kinetic energy of the second body, how to calculate? V2 is equal to M2 minus M1 divided by M1 plus M2 U2 plus 2 M1 U1 divided by M1 plus M2. Make sense? This whole value will be 0. Why? Because U2 is 0. Because U2 0. So what will be your V2 value? 2. What is the M1 value? 4M. U1 value? U. Total mass 4M plus 2M 6M. 2 3 the M cancel. Can we say it will be 4 by 3 U? Correct? Yes or no? Because for K2, I need final velocity. K1, it's easy. For kinetic energy, first half mass is 4m and velocity is u square. Correct? Now you calculate change in kinetic energy divided by total kinetic energy. Change in kinetic energy, half 4m is common. Initial velocity was u square. Final velocity will be, what will be the final velocity? 4 is common. So we can calculate u square by 9 divide by initial velocity half 4m u square. You can calculate. Yes or no? Tell me, guys, was it really difficult? First rule is you need to understand what is asked. Change in kinetic energy by total kinetic energy. How to calculate initial kinetic energy? Half mvu square. Mass is this. U is this. How to calculate change in kinetic energy? Initial minus final. Initial we already know, we have to calculate final velocity. How to calculate final? This formula done. Tell me, guys, was it difficult?
No, sir.
Then anybody have doubt, Sarah?
No, sir.
But focus on this word. What is the meaning of fraction of energy lost? Fraction of energy lost means change in energy compared to the initial value. You will every time see this word fraction of this change. So fraction means change divided by original. Change in x by original x. This is the fraction of anything. Okay. So we are done with it. We have to solve question. Today we will solve question. I think I have to take one more class only for question of this chapter today only. Okay. And but at 2 o'clock sharp you will have class and mm, we will do atomic structure in that class. But I will take a separate class whenever time permit.
Sunday, syllabus test, syllabus.
Sunday syllabus test. mm, this chapter full, gravitation chapter
Work
full.
energy power.
Huh.
Okay, sir.
Gravitation chapter full, and I will finish whatever is left from the kinematic. Okay. I will quickly revise the
Okay.
kinematic in 1 or 2 class because we are done with the most of the things. But quick review. So officially, first 6 chapter will be completely done. Last 3 chapter are also done. I'll do waves first, and then
Second,
in between mechanical property of solid and fluid. We will do that part in the end. What I am thinking. So 2 class maximum for kinematic, 2 to 3 class for gravitation, 3 class for okay. And not in
same
this
the
week, but
syllabus.
next week definitely I'll finish the full syllabus of 11th class before the end of the next week. And this week you will have work energy power, kinematic, and gravitation. Full, all 3 chapters. Okay. So be prepared for this. And Sarah, this week onward, you have to write a test.